వాడిబుల్ కాదు కదా.
Yes, sir. So, good morning, everyone. I welcome all the faculty members and dear participants and students for 3-day international conference on conventional and digital methods in chemical education 2021, CDMCE 2021. So, today we are in a third day and last session of the conference. So, this session will be chaired by Dr. Vishnu Shankar, Head Department of Chemistry, and co-chaired by myself, Dr. V. Rajesh Kumar. Now, I request Dr. Vishnu Shankar, Head Department of Chemistry, to chair the session. Sir. So, Vishnu sir,
The system got hanged. So, Dr. Vishnu, Dr. Vishnu Shankar.
It is hanged, sir.
ఇక్కడ ఎప్పటికి ప్రాబ్లం వస్తుంది ఆయన ఇక్కడికి వస్తే పోయేది వచ్చిండు కదా అక్కడ.
Hello, I am audible, no? Yeah.
Yes, sir, audible, sir.
Yeah, very good morning to all of you, the participants, speakers, invited guests. Senior
Dr. Vishnu, your voice is not audible. You are not audible.
Yeah. Hello, it is audible to everyone?
Yeah, it is audible to me,
Okay.
at least.
Okay, fine, sir.
Okay, good.
Very good.
Okay, please proceed.
Yeah. So today, third day of this international conference, on the 8th session, I welcome you all. So we are going to start the first lecture with Professor Venkatram R. Mireddy. So he is the professor of the Department of Chemistry and Biochemistry, University of Minnesota, USA. He is going to deliver on the talk on recent developments in our research lab using teaching lab chemistry and digital teaching innovation in upper level classes. With this, I request Dr. Rajesh Kumar, so please read the biodata, then after we will start this session.
Thank you, sir.
Dr. Rajesh Kumar, over to you.
Yes, sir. Thank you.
Dr. Rajesh?
We can't hear. Yeah. His audio is mute.
Yes, sir. Yes. Okay. Sorry. Yeah. So I'm very happy to introduce Professor Venkatram Mireddy. He's a professor in the Department of Pharmacy Practice and Pharmaceutical Sciences at University of Minnesota, USA, with a joint appointment in the Department of Chemistry and Biochemistry at University of Minnesota, USA. He obtained his BSc from Osmania University and MSc from REC NIT Warangal. Later, he completed PhD from IIT Kanpur in synthetic organic chemistry, working under the supervision of Professor Y.D. Vankar. He then worked as a postdoc in organoboron chemistry with the Nobel laureate Professor H.C. Brown at Purdue University, USA. He became an assistant professor in 2004, associate professor in 2008, and full professor in 2016, all at University of Minnesota, USA. Professor Mireddy is a co-author and inventor of 6 patents, more than 90 peer-reviewed publications, and more than 50 meeting papers. So far, 56 undergraduates, 24 MS, 10 PhD, and 5 postdocs have received training under his mentorship. Currently, he supervises a research team of 12 personnel, including undergraduate and graduate students. His research area is in drug development of small molecule anti-cancer, antimicrobial, and disease-modifying therapeutics for neurodegenerative diseases. Its lab students are highly trained in the organic, medicinal chemistry, in vitro and in vivo biology. They also have vast experience in conducting small animal experiments, including orthotopic surgeries. His research is funded by NIH, DoD, and various other agencies. Apart from the research, Professor Venkatram Meereddy is actively engaged in teaching. Professor Meereddy teaches mainly to the professional Form D students in pharmacy and graduate MS and PhD students of chemistry and biochemistry and integrated biosciences. Teaching responsibility include medicinal chemistry, integrated oncology, chemical biology, cardiovascular agents, and advanced organic chemistry. He received 25 teaching awards in the past 16 years, highest by any University of Minnesota faculty, which include Teacher of the Semester, Professor of the Year, College of Science and Engineering Young Teacher Award, and Outstanding Graduate Student Advisor Award. With this brief introduction of Professor Venkatram Meereddy, now I request
Thank you.
Dr. Vishnu Sankar, Head
Yeah,
Department
yeah.
of Chemistry,
Thank you,
to take
Rajesh.
over the
Thank you.
session. Okay.
Thank you. So,
Thank you.
with this brief introduction, so it is a benefit to the participants to have a prior to that lecture, so have a idea about that speakers. So, with this brief introduction, I would like to request Professor B. Ram Reddy to please start the session. Over to you, sir.
Thank you. Thank you all. And can you hear me nicely? I hope.
Yeah.
I'm going to share the screen. Alrighty. Thank you, Dr. Vishnu Shankar and Dr. Rajesh Kumar, for your kind introduction. It's a great pleasure. And thank you, Lakshmareddy sir, for inviting me on this wonderful occasion. It's always very, very nice to be back, at least digitally, if not in person. Being an alumni, it's always nice to see the developments in our department. And then I'm going to tell about, since it's a little bit about teaching-based conference. Yeah. So first I'll divide my talk into two parts. One is that I'm going to talk about some of my teaching methodologies that I usually do in upper level classes. Unfortunately, I don't teach any of the undergraduate courses. I only teach like PharmD, Doctor of Pharmacy, MS and PhD students. So, and then most of these students take only upper level classes. So compared to lower level classes where we can do a lot of digital innovations. So upper level classes, we are a little bit limited. But I'm going to talk about, as a case example, one of my course. And usually when I was in India, I used to go by the name Venkatram Reddy. But once I moved to US, so you have to have the family name as a last name. So that's how I became M. Venkatram Reddy to Venkatram R. Meereddy. In India, I never use the term M. So currently I'm at University of Minnesota. My primary teaching responsibilities are in College of Pharmacy, but I also have a joint appointment in the Department of Chemistry and Biochemistry, where I teach advanced organic chemistry course for the graduate students. Is it possible that somebody can mute the audio? I think background noise is coming. Alrighty. So, as I mentioned that, so I was the student, in those days, it was called REC, Regional Engineering College, Warangal. Okay. So I was 1988-90 batch. So many of you, obviously, a lot of the students were not even born. Even the graduate students, PhD students were not even born. So I'm talking about 31 years, 32, 33 years back. I mean, time flies, you see. Yeah. So first of all, I would like to thank my professors who taught me during my REC days. Okay. So left-hand side, I have all these faculty members. I know that many of these youngsters may not know these older faculty because they have long retired. So in those days, head of the department was Professor Adnan Reddy sir, and Professor Ramaya sir was there. He taught us analytical chemistry. Professor Y.D. Reddy, Dashrath Ram Reddy sir, he taught us organic chemistry. Professor Ranganaikulu sir, physical organic chemistry he taught. And of course, you guys, many of you may know, because Professor Ajit Kumar Reddy sir, he taught us the physical chemistry. And Professor Chandramouli sir taught a little bit spectroscopy, and then also about drugs and pesticides. And Professor Kankalingeshwar Rao sir also was there at the time. He taught us organic chemistry. And Professor Totar sir also organic chemistry, especially the natural products. I still remember the IL Finar textbook. It used to be a dreaded course for us because all those natural products, remembering them. And Professor Nageshwar Rao sir, he taught us analytical chemistry. Professor Buchireddy sir was there for a short period of time. He taught us mass spectrometry. And after that, he moved on to industry. And then he made a big name in the industry, pharmaceutical industry. Of course, all these faculty members have retired. And then today, Professor Ramchandra sir also is retiring. Okay. So, and of course, Professor Lakshma Reddy sir is there. And then when we joined in 1988, Professor Lakshma Reddy sir also joined at the same time as a faculty member. We joined as MSc students, and Professor Lakshma Reddy sir joined. His first appointment was in 1988. That's how time flies. So only faculty member after, of course, Professor ARC sir is there until today. So after that, then only from the older batch that whom they have taught me, only Lakshma Reddy sir will be available. Okay. Of course, over the years, I made good friendship. I made good friendship with Professor Rajita Madam. She also retired. Okay. Professor Rajeshwar Rao sir and Professor Apparao sir. Although they were not there at that time as faculty members, but I met them personally, and then I made good friendship with them. Okay. And all the current, I see that a lot of youngsters have joined the department, obviously. A lot of current faculty and staff members. I hope to maintain good friendship in future also with this all the youngsters, and then I can share some of my experience and wisdom of the old days. Okay. Thank you all for inviting me. First of all, I want to give a special tribute to Professor Ramchandra sir. Okay. I mean, as a faculty member, I know that at the time, in those days, Professor Ramchandra sir also was a very youngster. Okay. He joined in 87 or 86, I think. Okay. So only he was 2-3 years old as a faculty member in those days. Okay. So as a faculty member, all of us, okay, we teach our courses. Okay. And after that, we do our research. We work with scholars, MSc students, PhD students. We publish papers, and then we do some departmental service activities. That's all is the only thing most of us do. At least that's what I do. Okay. So, but Professor Ramchandra sir, apart from doing all these, the regular works of teaching, as well as publishing papers and then guiding students. Okay. So I really want to pay my special thanks and then special appreciation to ARC sir for his relentless and selfless service. I know that Jana Vijnana Vedika, and then so many things he was involved in, giving hundreds and hundreds of talks, going to schools, going to colleges all over the country and nearby places, everywhere, going there and then giving talks, and then to increase the scientific temper in India. It's not, and then to remove the superstition and believing the science. So this is the absolutely selfless service. I mean, giving once or twice. I also went to a couple of high schools and gave some science talks, but only just a couple of occasions I did that one. But giving hundreds of talks over the period of 30 to 40 years, It's not something joke. Okay. Remember that when you publish a lot of papers and when you do good teaching, it is quantified. Quantified in the sense that it is measured. And then you can always ask for promotion. Oh, I published this many papers. Because it's there on record, and then you can easily you can boast off. You can ask for the merit, you can ask for the promotions, everything. But whereas when you are doing this kind of selfless service, it's very difficult to quantify it. So in that regard, I want to thank you, sir. And then I hope that after your superannuation also, you will continue to help these youngsters in this noble cause. Alrighty. So I'll show you guys some couple of pictures. Remember that we didn't, in those days, it's a 1988-90 batch. Okay. So we were only 10 students in those days. It was REC Warangal in the thing. Only we were 3 boys. Okay. And there were 7 girls. So I think before that or after that also, our batch, I don't think anybody could beat the record number of girls in the same batch. Okay. I know that maybe now the girls wear pants and shirts and then Punjabi dress, but in those days only people wore saris. Okay, so these were my classmates, and then only, as I mentioned, that we were only 3 boys. I think so. This is what I used to look. Now, of course, I lost all the hair, and then I used to have a lot of hair. So we went to this 1000 Pillars temple in Warangal, of course. And we never laughed also. And most of the time, you know, that older pictures were very uptight. Okay? We never give. And nowadays, taking picture is so easy. You have all the cell phones, and then you take selfies, and probably you do the pouting and everything you do. Okay? So, or you post it immediately on the social media. So taking pictures is no piece of cake. Okay? So this is, of course, I may be looking like a little bit drunkard. But trust me, you may be thinking that I may have had a lot of 5-6 packs, and then so trust me that I was not, because we went to temple. Okay. So it's just that the photo came out like that. I looked at it, but I couldn't find any better picture than this one. So this is how we used to look in 1988, a long time back. Alrighty. So I want to show the picture of Lakshma Reddy sir in 1989. So one day, our MSc chemistry people, physics, and then math people, we decided that let's go to a trip. And then we were almost like 30 students together. We went to, within 2 days, we decided, and then went. Professor Lakshma Reddy sir joined us. Okay? As you can see that. So, I mean, he still looks very young. Okay? So in those days, it was 1989. Professor Lakshma Reddy sir picture it is. Okay? So this is what is my picture. I know that it looks a lot different than how I look now. So back in those days, we were all very lean, and we used to eat a lot. I mean, we used to eat. I mean, I used to like mess food a lot, and I used to eat a lot of food. But in those days, probably everywhere we walked. So that's the reason why we never put on weight. Everybody was very lean and skinny in those days. Okay. So this was one of the pictures I wanted to show. Unfortunately, I didn't have Professor Ramchandra sir picture and other faculty members, olden day faculty members, because camera was not that readily available to us. And then, so this occasion, we had this one picture. Okay. Over the years, I taught principles of medicinal chemistry for PharmD students, and then integrated oncology, cardiovascular agents, and then chemical biology. And for chemistry students, especially for master's and PhD students, I teach advanced organic chemistry too. Okay? Advanced organic chemistry 1 is taught by other faculty members. So advanced organic chemistry 2, mainly I do the synthesis part. And let me take out my phone, that way then I'm aware of the time. Okay. So rather than going through in the interest of time, I'll just walk you through what I do in my organic chemistry course. So this is the 8-level course. It means that it's upper level course. Okay. It's a 4 credits. It means that we meet at least 4 lectures per week. So on an average per semester, we have about 56 lectures. And so the course guidelines are like any other organic chemistry course, nothing special. You want to learn important concepts in organic synthesis and apply it in the field of medicine, materials, and other areas. But at the end of the course, I make sure that whoever has taken my course, they are able to write a reasonable synthetic scheme for any given molecule. Okay. And then also we do a lot of speed writing. I don't use the PowerPoint slides. I use whiteboard or blackboard. And then we do a lot of writing in that course. But the pandemic last year, what happened is that suddenly after 1 month in February, we went on a shutdown mode. So we had to become online. Okay. Within 15 days, we had to become online when this COVID started last year. Okay. In spring semester, I teach every year. Fall semester, they do the advanced organic 1. So I bought this tablet since we do the lot of writing thing. And then on the tablet, so we were meeting on the Zoom instead of in person. And then I was doing the same thing we were doing it. Instead of writing on the board, I was writing on the tablet. Okay. So thanks to the technology, so we could able to complete the course successfully. And I provide them, apart from the notes, I provide them a lot of supplemental slides, handout, and a lot of journal articles I will provide, okay, on a regular basis. So some of the syllabus, and depending upon 12 to 14 chapters I tend to cover, but over the years I realized that students are not able to pick up that readily. So on an average nowadays, I teach about 11 topics in that semester. But back in those days, I used to teach 14. So usually I start with reduction, oxidation, alkylations, allyl metals or organometallic reactions, olefination reactions, olefin metathesis, okay, cross-coupling reactions, all these modern organic chemistry reactions I do. And then eventually we discuss about how using all these tools, how we can synthesize these complex natural products. Okay, because one of the goals is that at the end of the course, the student should be able to write a reasonable synthetic scheme for a complex molecule. And then what I do is that I give them 3 homework sets, 10%. They'll be usually they are based on straight notes. I give them about 3 homework sets over a period of semester. So that translates to easily 30%. Okay. And I give them take-home exam. Usually I'll walk you through what kind of take-home exams I give. And then I also give take-home exam 2, a big molecule writing. So that's about 30% of the credit. I give them about 15 days time they can do at home. And then I give them in-person comprehensive finals. That's about 20% thing. And standard grading, nothing special. In graduate courses, we don't allow D grade. If you get a D grade, it means that you have to repeat the course. Okay? C is the maximum allowed grade. And then above 90, we give the A grade. So some of my homework problems, I hope that you guys can see it. I just took the picture of my last semester's organic chemistry homework. For example, this is based on the reduction thing. They need to fill in the reagents, but most of them I taught them, so students are usually very comfortable in doing it. And then I do a lot of asymmetric synthesis also I discuss, as you can see that. So they are filling in. It's a straightforward questions. There's nothing tricky in doing this homework, just so that they're in the mode of solving the problems. So usually I give them 3 of them, easily about 30 to 40 questions I give them for each homework. So about 100 to 120 questions when you combine all the 3 homeworks. Yeah. Can I request the audio mute, please? Yeah. Maybe. Yeah. Thank you. Okay. Apart from the thing, I give them the comprehensive finals, and comprehensive finals is it's open book. I give them open book means they can bring in their notebooks or textbook or computer, as long as they are not talking to each other. Usually it's 3 hours comprehensive finals, but they can do whatever the way they want to consult. They can do the internet search or SciFinder search or whatever the searching they can do it. So usually I give about 10 to 12 problems to solve, and mostly I pick them from literature, latest literature, and based on the concepts that have been learned throughout the semester, they're expected to solve these problems. For example, identify the reagents and structures of the products in the reaction sequence below. Since an open book, so I always tell them that think that it's a closed book exam and go through the reagents, reactions, make everything very carefully. Just because it's open book doesn't mean that if you come unprepared, you'll be struggling. That's what I repeatedly tell them. Okay. And it's about 20% of the total credit. If they mess up in the finals, then what happens is that then they will not be able to get the A grade. So you can see that most of these structures, they have to fill in, and then eventually they have to come up with these products. Reagents, they have to fill in. Okay. For example, one from the literature. So, but most of the tools I would have already provided in the semester. So if they're if they know, they'll be able to write this without any problem. But of course, they can always consult computer and then internet and then notes and book and anything. They can do it. And also, one more example of the comprehensive open book is that how do you prepare the following 2 compounds in enantiomer and diastereomerically pure form, starting from benzaldehyde in not more than 3 steps. They have to start from benzaldehyde and then synthesize these 2 small molecules, but they have to take only 3 steps. Okay. So like that, I test them in the open book comprehensive finals. And as I also mentioned that I give them 2 take-home exams. So this take-home exam is that depending upon how many students are there, in some years I have 10 students. It's a graduate level course. So it's not undergraduate course. It's not the BSc level course. So it's usually MSc and PhD students take it. So usually about 10 students. On a good year, it's 12 students, and sometimes it's only 8, 9 students. Yeah? Because they can take other courses also, because it's not a compulsory course, it is. So so they have a choice of taking, and those analytical students they take, usually organic students, inorganic students are interested in taking my course. Okay. So I give them, for example, if there are 4 students are there, and I give them 4 molecules, and then I pick them through lottery. So they get 1 molecule each independently. So they have to write, it's a take-home exam. I give them 1 week time. So they have to provide a synthetic scheme. And so they have to see if they were given to, if they have to make this molecule, how would they make it, at least on paper. Okay. So they have to write and then explain their choice of reagents and reactions briefly, like a couple of sentences. Why did you choose this particular reaction? Why did you choose this particular reagent? Like that. So this is a small molecule writing. So it's usually after 2 months into the course, I give them based on the concept learned at the time. And I also give them a take-home exam, which is 30% of the total credit. Okay. So I give them usually 15 days. At the end of the semester, they have to submit. They have to do it, ChemDraw, they have to draw it, and then usually it takes about 40 steps, 50 steps. Sometimes they take 30 steps. It's a huge total synthesis they have to write. And again, I pick them through lottery. If the 15 students are there, I give the 15 molecules, and then each one, they pick their own lottery. And then if they get the number 4, I assign the number 4 molecule. Okay. I already predetermined the numbers for each molecule. That way, then they can't copy from each other. Everybody has a different molecule. They have to solve it. But I'm giving them 15 days time, and they're doing it home. And so they can do any type of synthetic thing, because that is what is the end goal of this particular course, because they should be able to write a reasonable synthetic scheme for any given molecule, especially for complex molecules. They should be able to write it. Okay. So, and then I also do that 10% for retrosynthesis, and then also 10% for strategies to be employed, and for 50% for using the correct reagents in the schemes, explanation of the choice of the reagents, and eventually they have to, because they are breaking the molecule into 3-4 pieces and then stitching them together. So stitching together the subunits. So all these points are divided, and homework problems, take home exam 1, take home exam 2, in-person comprehensive open book exam. So eventually that translates to 100%. And over the years, students have done really well. And in fact, Shirisha, who was NITW alumni, who is in the audience, was my PhD student also, and she did very well. She topped that particular course also. So this is about the thing that usually we use the Canvas site thing, but this is in this particular course, I don't do that much digital innovations because it's a small class, and then I prefer to use a lot of writing, because organic chemistry, you can't just learn it just by flipping through the slides. It's difficult to learn it. The more you write, the more comfortable you become. And then also we do a lot of speed writing, because I challenge students that when I'm writing, they should be able to write it. And then, so that way, then they are very comfortable in writing the chemical structures also, not just the alphabets, but the chemical structures also. Okay. So this is about one of the course, organic chemistry, and some of the things that I do. Okay. And now I'll talk a little bit about research and how I use simple MSc lab chemistry, how I've incorporated a simple chemistry, simple organic chemistry into my research. So initially, as a starting assistant professor, long time back, so I used to make this kind of complex molecules. As you can see that this discodamide, the blue looking molecule, we synthesized it, and then we published, because it's this particular discodamide molecule. As you can see that it's a marine national product, and it's a complex molecule with a lot of asymmetric centers are there. Okay. And so we synthesized this particular molecule, we broke them into 3 units, and then asymmetric synthesis, we have done it. Out and out, back in those days, I used to do organic synthesis only. Long time back, I'm talking, because that paper was published in